Thomas. I am Regional Sales Manager for Quebec and Ottawa Valley. So what is a 70-volt high impedance system? Basically everybody dealing with TOA is using a lot of those, but it's always good to have a refresher reminder of what it is exactly and how can we design an efficient system and what are the the rules of thumbs when it comes into designing this type of system. So what is a 70-volt high impedance system? So basically it is a system that is designed to use speakers that are working under high voltage like 100, 70 or 25 volt. In North America and Canada, we use 70 volts, 70 volt basically as speaker load. Those speakers will have power taps, so a transformer with power taps on it, and the taps will normally move in 3 dB steps. The amplifier will have a high voltage output with an high impedance output of 25 and 70 volt, sometimes 100 volt, but we see that more in Europe than in North America. So this high voltage delivery will assure that the speaker volume is not affected. And this type of system will be basically mostly used for distributed speaker system. So when there is a large numbers of speakers to be installed in a project. Over here we see the typical example of speaker tap on the F-series ceiling speakers. So this is a transformer that we're using on the F122, 2322, and 2352C. So different taps are available to us there, from 8 ohm to 30 watt. So we do have an 8 ohm and a 16 ohm power taps, as well as 70 volt and 20 volt power taps, all indicated on the tap selector that is on our high quality ceiling speakers. And normally those will attach to the speaker output of a 70 volt amplifier. We see there the output, the speaker output on a BG type amplifier. So we have a 4 ohm, a 25 and a 70 volt output available to us there. So low impedance versus high impedance, basically the difference will be the ease of installation of the 70 volt. When we're talking about low impedance speaker, basically this can become a very complicated system to install in regards of cabling of those systems. So when we're looking at the 8 ohm speakers, and we cannot just add them one after the other. Actually, is that each time that you add an 8 ohm speaker, you will get a lower impedance when it's parallel cabling or parallel connections of those speakers. So the basic math of those systems would be the nominal impedance of your speakers. So in this scenario, 8 ohm, which is the most popular impedance, low impedance speaker rating, divided by the numbers of speakers I want to use, and that's going to give me the overall impedance of my system. So to make it simple, 8 divided by 2 in this scenario, we'll have a total load of 4 ohms. So in order sometimes to work around the overall impedance of the system, we will get into serial and parallel type of cabling in order to maintain this speaker load and this impedance, overall impedance load. And when we're going serial connection, then the math are different. When you had two 8-ohm speakers, you will multiply in serial the overall impedance. So again, in this scenario, two 8-ohm speakers times 2, you will have an overall impedance load of 16 ohms. When doing 70 volts system, well, it's way more easier. You will just daisy chain those speakers one after the other, and the only limitation that you will have is the wattage or the power of your system. So in this scenario, we have 5 speakers, all tap at 1 watt each. Well, we have a 5 watt load. If we would have 40 speakers, we would have only 40 watt load on our system. So there's a lot of advantage using high impedance system. We have understand that the cabling, the wiring is easier. So they all connect in parallel. There's no series wiring required. There's no need to, calculate the impedance load. It's very easy to manage. Actually, when there is a failure of a speaker, this will not affect the complete system, but only that speaker. Also, because of the transformer on the speakers, it will give you the ability to adapt your system to each zone and the ambient noise of each zone. While moving or adding or removing a speaker will not affect also the existing speakers of the system. We can do fairly long speaker cable runs with the appropriate gauge of cabling. Also by using higher voltage output, well, it's giving us the ability to use a smaller gauge. Also, we will be able to use a simple 70 volt attenuators or volume control in order to manage the volume of each zone. Here we see the basic diagram representation of a 70 volt system, and what is comprised in this type of system. So in this diagram, we see here that we have a background music source, we have a paging microphone, we have a 70 volt mixer amplifier package, like the BG or 700 series or whatever amplifiers that we see there. We have 70 volt speakers and also the implementation of a volume control, an attenuator. When we're doing system design, basically, in order to do a good design, we will have to answer several questions before we go forward. First of it is, first question that we will need to address is where we'll be using those systems. Is it inside or outside? So if it's outside, we will have to select some weatherproof speakers. Inside, what is the acoustic of that room that we need to install the system in? Will I select some wide or narrow dispersion speakers? Depending on this acoustic, is it highly reverberant or not? Is it a fairly decent acoustic room? What is the size of the room? We'll need to measure out length, the width, and the height of the room. What kind of ceiling do we have in that room? Do we have a plenum type ceiling? If so, we'll need some plenum rated speakers. What kind of ceiling is it? Is it tile ceiling, G-Proc ceiling, etc.? So this has to be noted down in order to work on your design. What will the system be used for? Obviously, even 70-volt system or low impedance system might be used for different type of application. So is it simply for background music? Is it for foreground music? Is it for paging? Is it for signaling? Is it for all of that at the same time? And also, a lot of customers will ask you to install you a system, but what are the expectations of your customers in regard of the quality of the audio? Is he looking for a high-end system? Is he looking for background music with extended bass? So is deep bass required? Or is it only for speech or paging? What kind of intelligibility is expected from your system? We will also need to find out how loud do we need the system to be. So we need to find out exactly what is the ambient noise level of the room that we need to install the system at. So for this, you might need some dB meter in order to measure out the existing background noise that you have in the projected room. And also we have mentioned it earlier, but will we be broadcasting foreground material on the system? So we might need to achieve some louder SPLs. The other question that we need to answer is how and where are we going to mount the speakers? So is it ceiling mounted speakers, wall mount speakers? Are we going to fly the speakers? So we'll need to select the right brackets in order to install our speakers, or the right hardware in order to fly it or wall mount your speakers. If we're using subwoofers, also, how are we going to install it? Are we going to just select subwoofer box that will sit on the floor? Are we going to fly it? Are we going to install it in the ceiling? This will all help us to select the right equipment for our application. What will be the speaker spacing be? Well, this will depend on the pattern that we'll be using, and what type of performance level we need to attain. This will help us to determine the speaker spacing between each of them. Also, we need to find out what amplifier power and cabling is required. Well, actually, this will depend on the numbers of speakers and the power setting and the power tap of each speakers that we have in the system, and also this will be fixed around the final performance of the system that we need to achieve in regards of the ambient noise and the expectation of your customer, etc. And the cable gauge, well, you'll find out exactly what the type of gauge that you need, depending of the power of your system and the length of the run of your cable. Other important question that we need to address is, do we need DSP? Do we need signal processing? Our speakers, like the F122 or other speakers, will benefit of having some DSP, as they need some active equalization in order to give you a complete frequency response. Also, you might need DSP in order to improve the sound quality, in order to also work the acoustic of a room, or to reduce feedback, as an example. Also, if you need muting capabilities, DSP engine will help you to give you good muting capabilities. And also, DSP will give you the ability to have leveling and compression in order to maintain your volume level and prevent damage to the equipment, or just to maintain a certain level of distribution. Do we have a multiple zone system? So do we need several amplifiers or several amplifier channels? Do we need to deliver different audio source in different zones? So maybe we need some matrixing, audio matrixing in our system. Also, some zone paging may be required as well. So if this is the case, well, we might be using 9000 M2 audio matrix along with some DA series multiple channels power amplifiers. Other question that we have to address with your customer is, what are the needs? What is the material you want to broadcast? So this will give you the sound source that you need for your system. So are we going to page? If we do page, are we going to page with a microphone? Are we going to page through the telephone system? Are we going to use the ZP module to do zone paging, or simply one zone from the telephone system? Are we going to page from a desktop microphone? What type of music source is going to be broadcast? So this will help you also to supply to your customer the right background music material equipment, like the CD or a DVD player, an MP3 player, a computer, whatever. Do we have pre-recorded messages? Do we have signaling? So we do have also some message repeater or modules in order to broadcast pre-recorded material. Also, we need to find out if, again, we need the muting. So if some of those material need to be mute and give priority to certain messages or certain paging, this has to be taken under consideration. Even do we need to be override by a fire alarm panel, as an example? Those are all questions and situations that we have to take under consideration to design our system. So, at the light of all those questions that we have asked and answered, well, which type of system am I going to provide? Am I going to provide a high or a low impedance system? A low impedance system normally is going to be selected for performance, or for larger halls, auditoriums, sport complex, arenas, example. You have to understand that it will take heavier gauge of cabling. Also, the final cabling might be more complicated. and you will need to take under consideration to maintain your impedance load in order to have a good system, a good working system. The high impedance systems will be more suitable for zone paging, background music distribution, or smaller areas for PA application. But you will need smaller gauge of cabling, simplified cabling layout as well. You will have the ability to install simple volume controls, 70-volt volume controls like our 80 series. And basically, you won't have to calculate the overall impedance of your system, since 70 volts, it's way more easier. So, now that we have asked all of those questions, where do we start? We need to find out exactly at what SPL we need to be in order to achieve the performance that our customer is expecting. So, in order to find out that, we're using decibels as a measurement. So, the typical dB average is from 0 to 140, and 0 being normally no volume at all, no sound at all, and 140 dB, very, very loud system that might cause permanent hearing damage. So a couple of reference example, 30 dB, it's like a soft whisper at 5 feet, 50 dB, that's the ambient noise that we'll have in a private business office, 70 dB it's average male conversation, 90 dB truck traffic, and 115 dB is a rock concert, so it's very loud at 115 dB. Typically, average people will notice a change in volume with a 3 dB change, and will have the impression that the volume has doubled with a 10 dB change. One of the things that we'll take under consideration to design our system is the speaker sensitivity specification. Normally, all the manufacturers will give you this type of specification, and it's measured out in dB. And typically, all the manufacturers will give you a rating in dB as 1 watt, 1 meter, and the performance and the sensitivity of your speaker. So the higher sensitivity is preferable, because we'll need less amplifier power to boost the system. So if we need to vary the power, so what does it represent? How will I double the power of my system? So if we take this reference, in that case, we're talking about 90 dB, 1 watt, 1 meter. In order to have 3 additional dB, we will need to double up the power. So if we change the power tap on the speaker from 1 watt to 2 watts, we'll go from 90 dB to 93 dB at 1 meter. Going to 4 watts will give us an additional 3 dB, so we'll have 96 dB at 1 meter, and so on. So if we look below there, we'll see that from 1 watt at 90 dB, 1 meter, if we tap the speaker at 8 watt, we'll have 99 dB at 1 meter. We need to figure out also, to design our system, the inverse. How much volume am I losing with the distance? So basically, with a conventional speaker, each time you double up the distance, you're losing 6 dB. This is not true for line-array speakers. You will lose only 3 dB, but for our example today, will take under consideration that we are losing 6 dB for each doubling of distance. So our speaker that have a 90 dB, 1 watt, 1 meter, at 2 meters will give us 84 dB. If we move 4 meters away, then we'll get 78 dB. So again, below this example, 1 watt, 1 meter, we have 90 dB. At 8 meters, the SPL of that speaker will be only of 72 dB. So why this is important? Well, it is very important in order to design the right system for our application and to figure out what is the power of the system I will need for my project. Let's again take a look at our example over here. So with our speakers at 90 dB, at 1 watt, 1 meter, we want basically to achieve at ear level a system that will give us 84 dB. Okay, so basically what we will do is that we figure out that at 4 meters, which is ear level from my speakers, if I keep my tap at 1 watt, I will have only 78 dB. So in order to get to 84 dB, I will have to change my power tap to 4 watts. We have 1 watt at 78 dB at 4 meters. So I have increased the power to 2 watt, which gives me 81 dB, and to 4 watt, which is giving me 84 dB. On the F122 and our speakers, the closest tap is 5 watts, so at 5 watts, I'm going to have just a little bit over 84 dB, which is very fine. And what happened off axis of my speakers? So same thing. If with the distance we're losing 6 dB, well, off axis at 30 degrees, we also lose 6 dB. So to make a good design and to make sure that we have an even sound all across the room, well, we need to take that under consideration also. So why it's important? Well, in order to make sure that my system doesn't vary too much and I have an even coverage, well, I'll make sure that the off-axis, my spacing is going to be good enough so I don't lose more than 3 dB in order to keep my sound pressure at a good level everywhere, a good even coverage. And if we use paging horns and they are angled at 10 degrees, like we have an example over here, well, same thing. 30 degrees, well, we'll lose 6 dB. And this will change also the spacing of my speaker. You can see over here that we have 50 feet spacing at 20 feet ceiling height. So basically, how much amplifier power I need in our example with my 90 dB speaker, efficient speaker, I need to tap it at 5 watts in order to achieve the SPL I wanted. So finally, at the end of my design, I find out that I needed 19 speakers tap at 5 watts each, which is going to give me a power load of 95 watts. And we need to calculate a certain headroom in order to accounts for peak signals and protection of our speaker system. So we're always calculating around 20%. So we have 95 watts plus 20%, which is going to give us 114 watt. So for this typical system, I will select an amplifier of 120. So I need a quote on an audio system in a room that is 50 feet wide by 100 feet long. So we see that that's not enough. We really have to ask way more questions to make an efficient system. What is it used for? We don't even have the ceiling height there. Is it going to be for background music, foreground music, PowerPoint presentation, DVD material, paging? Is it going to be for live band? So, you know. So what is the difference between point source and distributed sound? Well, the audio is coming normally from the front of the room, and normally with a point source, you will have a pair of speakers that are set each side of the stage or the presenter in order to focus the audio and drag the attention to the presenter or the stage. So the pros and the cons for a point source will be the pros, well, the ceiling is too high and it's not suitable for a distributed system. We want to draw the attention laterally. The cons are, well, audio will be probably too loud if I'm too close, and I will have minimal throat distance. And for distributed, we can see that the pattern is more even, and the audio is going to be reproduced all across the room more evenly. So pros are, effectively, we have more even coverage, a non-obtrusive look. The size of the room is not a factor. We'll just add some speakers as the room gets bigger, and then it's going to be easier to cable. Well, cons are that they will be limited to the size and to the power of the system. The ceiling material will maybe restrain certain install depending on the type of ceiling and the ceiling material that we have in our project. How much amplifier power do we need? Once again, we have decided that we will have a distributed system. We have selected a speaker with a 90 dB efficiency. We have calculated that we need to produce an SPL of 84 dB at the ear level. So in regard of that, we have selected the 5-watt tap out of our speaker, which is in this scenario an F122C. And we have done a proper layout of our room, and we have calculated that we needed 19 speakers. So once again, 95 watts with an overhead of 20%, 114, selected the 120 watt amplifier. So this is one of the tools that you can get from your local RSM. It's just a small design worksheet, which is basically a point of form of all the questions we have asked over here today. So what type of application, what type of room, do we have environmental consideration, waterproof, explosion-proof, etc. Are we doing paging? Are we doing zone paging? Do we have background music? What kind of audio source are we using, etc.? Do we need volume controls? So basically, all the questions and even more are resumed in this worksheet, and will be an excellent tool for you on site in order to take notes on your project and be able to provide your customer with the proper equipment for a system. Another very interesting tool available at TOA is our SPV software that you can download from our website. Basically, you will be able to do complete design with this little software, proper speaker placement, etc. You will be able also to determine the type of power that's going to be required in order to achieve the performance that you wish. So it's a very interesting tool, and we even have a webinar strictly on the SPV in order for you guys to understand more this software. Charts also are available from our tech support team or even your RSM for the cabling. It's going to give you basically the gauge of the cable that you need in regards of the power and the length of the run that you're installing. And a couple of other tools that is very interesting. It's our speaker guide and amplifier guides, both of them available from TOACanada.com. Don't hesitate to download it. So at TOA, we are probably, it's one of the reasons why we are what we are now in 2014 is the recognition that we got from the market with our 70-volt products. So we really have wide choice of 70-volt equipment, from the small BG 3-channel amps to our 9000 M2 8x8 matrix, available with some 70-volt built-in power amplifiers, our digital amplifier as well, the DA series, available in different formats from 2 channels at 250 watt up to 4 channel at 500 watts. And also all our speakers available for all of your needs and all kind of different installations.